Bonjour. That's about as good as my French gets. So unfortunately, I'm going to be speaking in English for the rest of it. Yeah, we're here today. We're going to be presenting the Encore project, which is energizing coasts with offshore renewable energy. It's an Interreg project. We've got myself, Bevan WRAY from Inyanga Maritime. Do you want a quick introduction?
Yes, I'm Laurent DERVAUX from Bureau Veritas Solutions, and I will present my part after Bevan. And we have also Anne Levasseur here, who have worked on the project for Artelia.
Excellent, thank you very much. Yeah, so today we're going to be presenting about the Encore project, and the topic is advancing for offshore renewable energy solutions, risk and reliability management from design to installation. So just a quick introduction to the project. Encore, as I said, energizing coasts with offshore renewable energy. It's a project which started in the very start of 2020, just before the pandemic, unfortunately. So we've been pushing through that, and we're still on target to finish, thankfully, on the original date of June next year. So the project is a 5.9 million project funded by Interreg, as I said, and we've also got additional funding by several Dutch regions as well. Oh, is that right? So the consortium, we're 12 partners from the Netherlands, Belgium, UK and France, a cross-border project. And we're split into two streams of partners. So we have technology developers, 4 technology developers, which I'll give an introduction to in a minute. And then we also have 6 technical and commercial service providers. And the setup is that the technology developers are able to benefit from the services of the service providers and de-risk the technologies, essentially. We then have Met Support, and DEFTIC, who are our communication and project managing partners as well. So the objectives of the project, 2 main objectives. One, obviously, is to advance the 4 offshore renewable energy technologies which are involved in the project. These are water to energy, teamwork technology, oceans of energy, and Eel. And then the second objective is to de-risk the technologies, as I said, with the service providers' expertise. Each sort of marine energy expert in their respective areas to help de-risk the technologies, and then also prepare the developers for the next stage in their development. So larger scale testing, but also preparing for investment and the commercial roadmap, essentially. So this slide just gives you an illustration of the project and how it operates. So down the middle, you see the 4 technology developers, and on the left, we have the service providers. So each service provider has been applying the IEC standards, different IEC standards to each technology to help de-risk the process from design all the way through to prototype deployment. So we had BV on technology qualification and certification, which Laurent will describe in more detail later. Artelia supporting on resource analysis, so identifying a site, modeling that site to output the characteristics to support both on energy yield analysis, but also to feed into the design, key design parameters. We then had ourselves, so we're supporting on the design aspects, mainly around offshore installation and O&M, as I'll go into in more detail later. Scale testing with University of Ghent, so taking key innovations from each technology, testing that at smaller scale to, again, de-risk so that it can be deployed at larger scale in their next stages. And finally, European Marine Energy Centre, or EMEC, and the Dutch Marine Energy Centre, DMEC, supporting on the large-scale prototype testing, looking at load measurements, acoustic measurements to really de-risk on a commercial basis as well. So then each of us has been applying the IEC standards to each technology, and then as an additional sort of objective, we've been taking the learnings from that and feeding it back to the IEC, hopefully so that it improves the friendliness and applicability to the sector as a whole, and that it can benefit the marine energy sector as a whole rather than just the technologies in our project as well. So I'll give a quick introduction to each of the technology developers. First, we've got Teamwork Technology. So Teamwork Technology are a point absorber styled wave energy device. It should be a, yep. So as you can see on the screen, it's a tubular device. Works by the pressure of the waves passing over the device causes an external tube to rise up and down. And then within that acts as a vertical displacement pump, essentially. So pumps the fluid through an internal turbine, which obviously then generates electricity. So within Encore, Teamwork Technology have done dry testing. So they're taking a very stepwise approach to their development, dry testing within Encore, and now they're looking to secure further funding to then take that offshore, and we're working with them on that as well. The second is Eel Energy. So Eel Energy are a French tidal energy developer with an undulating membrane device. They've got a video, so I'll just let this play for you. There we go. No worries, no worries. Okay, so we don't have sound, unfortunately, but I can try and describe the device. So Eel, as I said, it's an undulating membrane device. It's based off biomimicry, so mimicking the efficient way in which sea mammals, fish swim through undulating their body, and taking that and applying it to marine energy and tidal currents. So as you can see here, the flow over the device causes it to undulate, and then they have a power takeoff system integrated within that to generate electricity. One of the main advantages with the Eel device is that it's able to harness very low flows compared to other tidal energy developers, which are generally horizontal axis turbines. So this can go in very low flows. Also requires very shallow depth, so it can be applied in rivers as well, which really creates a wide market for the Eel Energy device. So within Encore, Eel have worked to improve the reliability of their membrane, and they've also done 2 iterative small-scale tests. So one in a very small scale in a small canal, and now they're working to deploy in a real environment in a tidal flow. Next is Water to Energy. So Water to Energy are a vertical axis tidal turbine developer from the Netherlands. Unfortunately, they are also a video. So
see here is our latest generation of our water turbine, which will be installed at the locks in Vlissingen in the province of Zeeland in the Netherlands. And it is part of the Encore project. And we designed and built a completely new vertical axis turbine with controllable pitch blades. The installed power is 100 kilowatts. Should be sufficient for supplying energy to 100 households. Right now we are testing the positioning of the turbine in its final position, and we hopefully within the next 4 weeks we can complete the final installation and start operations. So the next phase for this project will be testing the unit in operations, the efficiency, the workability, the newly designed controllable pitch technology, and well, we look forward, of course, to good results. So for the next future, well, we hope to develop more of these units, and based on the experience we have now and for this project, a bit larger scale turbines, but also for open water, on pontoons or on rivers. But our main focus of the product is this type of locations, so in sluices, locks, dams, barriers, to make use of the water flow. In this case, on the other side of this dam, there's a sea, so at low tide the water will flow out, and at high tide the water is allowed to flow in. So basically we will have a energy production for a large part of the 24 hours. We're looking forward to the results, and thanks for watching.
Okay, and our final developer is Oceans of Energy. Oceans of Energy are a floating solar developer, again from the Netherlands. Within Encore, they've expanded their system and demonstrated it in a more harsh, further offshore environment. So I'll hand over to Laurent now.
Thank you very much, Bevan, for this introduction. So now I am going to present you the part performed by BV and BV Solutions, who has worked on the risk assessment to help on the qualifications of these new technologies. So just a quick introduction with Bureau Veritas and Bureau Veritas Solutions. Bureau Veritas is very well known. It's a very large testing, inspection and certification company, as you can see with these figures. And it is the largest such body involved in the wind classification market. It includes 340 wind professionals, which are located in key hubs in Europe, Asia, and USA. And it also benefits from a network of surveyors which are present in 140 countries. We are both present in the fixed offshore markets, of course, and also now with the pre-commercial farms in France, we are also present in the floating wind market. So BV is also present in all the offshore renewables energies, such as tidal, wave energy converters, or OTEC systems. Regarding Bureau Veritas Solutions, it is a subsidiary of Bureau Veritas Marine and Offshore part, and it is dedicated to provide non-class services, whereas Bureau Veritas Solutions will do the classification and statutory services. So this has been made to avoid the conflict of interest between the one who is doing and the one who is doing the certifications. Bureau Veritas was created in 2017, and it gathers the non-class activities, as I said, on the basis of Hydrocean, former company Hydrocean, well known for the hydrodynamics computation, and Technitas. And it's basically Bureau Veritas Solutions is helping to do decision making to his clients. One good example to illustrate the difference between Bureau Veritas and Bureau Veritas Solutions is that regarding the new vessel of Jan de Nul, the wind turbine installation vessel, which will be the largest jackup in the world in the next year, Bureau Veritas has been doing all the structural verifications. Hand over to Jan de Nul and his architects, who is doing the approval dossier, and this approval dossier has been certified, or is being certified by Bureau Veritas. So Bureau Veritas Solutions is doing engineering, and in this engineering, risk analysis. We are working in the environment for the energy transition, and of course the offshore wind. We are doing some smart shipping with digitalizations. We do also audits and surveys on ships, and we also have a focus on e-training. So regarding the engineering solutions, from the former Hydrocean, we do a lot of high-level hydrodynamics, computational fluid dynamics, and aerodynamics for the ships. We do ships structural checks, marine analysis, vibration, noise, etc., etc. So regarding the risk, we have a strong team which is doing many valuable works in the marine industry with ASID, ASOPS, FMEAs, FMECA, and new qualification of technologies, risk assessment, quantitative risk assessment, including fire, explosion, evacuation, etc. So going back to the Anchor project, what is the context and what are the reasons for the risking and performing technical qualifications? Well, first, all the stakeholders need a common guidance and evaluation tool so that they speak the same language to safely develop the technologies. So first, the designers, they need a framework to develop the technology. And also the project developers, the investors, the insurers, and all the other institutions, they need a consistent means to assess these innovative technologies. And also, we have also the burden of the cost of capital. And this cost of capital is depending on the return of investment expected by the investors. And this depends on the risk profile of the companies. So the lower is the risk profile, the better will be the lower will be the cost of capital. So this will decrease the cost of energy. And the risk analysis that was conducted during this Anchor project was based on the EIC TS 62600. Which is a specification for establishing qualification of new technologies for marine energy. And on the BV guidance note, risk-based qualification of new technologies, methodological guidelines. And this is a risk-based approach, focused on performance, rather than fulfilling prescriptive approach with given standards which currently are not yet set up. So what is qualification of new technologies actually? So qualification of technology differs from ordinary certifications because it will allow systems to be qualified that do not conform to an existing standard. Or they partially conform to an existing standard, but not completely. So they need some qualification. It is a process by which the novel technology will be validated and also validated in a new context. It can be a technology which is already existing, but applied in a new context. So we take this into account. So it is based, of course, on theoretical analytic modeling and physical testing, dry test or full scale where possible. So the final aim of the qualification is to provide evidence and arguments to support claims of the technology developers that the technology and the assessment will function reliability in the target operating environment under specific limits and with an acceptable level of confidence. So here we have the different steps of the methodology. So on the top right corner you can see the figures that is extracted from ISC TS 62600. So it is It is a workflow that is used widely for decades, among others in the offshore industry. And it is also based on BV guidance note NI 525 and on some return of experience. There are 6 steps, which I will describe briefly. So first is a technology definition. We are going to look at the requirement of the device, the specifications, the operating conditions, and the performance and reliability targets. Then the system is breakdown into various subcomponents. And on the step 3, for the various subcomponents, we are going to determine the degree of novelty. So every subcomponent will have his own initial TRL, technology readiness level. And then we apply to this what we call an integration readiness level, which has been set between 1 and 4. And this will modulate the TRL, and we will get an adjusted TRL. Then using this TRL, we are going to perform what we call a technology class assessment, and with 4 levels. And class 1 will have to follow what we call a criticality assessment, which is for step 4. During this step, we are going to look at the criticality of the failure. Will we just lose 1 day of production, or will we lose the entire system? It is two different, very different aspects. And using this criticality level, and in step 5, we are going to combine this with the probability of occurrence, and we will determine quite classical matrix, which will determine what we call the criticality levels from C1 to C5. And for the criticality levels 4 to 5, we will state that technology plan assessment, technology qualification plan, will be needed. So this is the step 6. And some keywords for this technology qualification plans are definitions, acceptance criteria, recommendations, comments, schedules, and this is applied to various categories such as engineering analysis, testing, manufacturing, surveys and inspection, quality, etc. So on the bottom you see the various steps that has been followed by all the people. So first review of the documentation, then there is a preparation for the workshop with the various people, and then there is a workshop which will last 2 or 3 days with an FMICA, and then there is lastly a review of the technical qualification and certification plan. So at the end of the day, we have studied 3 technologies: floating, tidal, and wave energy converters. There is a focus on the very specific failure scenarios that was identified, the one with the higher criticality. And this has led to the identification of 74 qualification activities. And now the people, the technology developers, will be able to develop their technology based on a technology qualification plan. They will act safely, and this will enable them to improve their TRL. And lastly, there is a feedback also of all these activities. As you see on the left column, there are some deliverables from the Encore project which are linked to some work groups in the ISE, and all the deliverables will be used to implement the ISE specification, so that they are up to date and they follow the technology, or they precede the technology, and this will be able to be used by the other technology developers. here we are. I leave back the floor to Bevan for the continuation of his presentation.
Thank you. Yeah, so we're Inyanga Maritime. Going to present on risk and reliability, installation, and O&M. So just quickly, who are we? So we're specialists in offshore operations, engineering, consultancy for all marine energy sectors, wind, floating wind, wave, tidal, and floating solar more recently. We're an end-to-end EPC service provider. So yeah, as I said, consultancy all the way through to actually going offshore and deploying these technologies, maintaining them for clients. Our team has got quite a diverse background, starting in offshore oil and gas, and then those skills have been applied to the marine energy sector, especially tidal energy. So we specialize in tidal out of all marine sectors. The team has deployed over 60% of Europe's total installed capacity. Capacity is quite small, but still a large percentage. So that's where we specialize really. And throughout, I'm going to sort of use tidal as my example for the rest of the slides, but it's all applicable to all marine energy sectors. So this, just a quick slide to show how important installation and O&M is. So in the green here, this is the pie chart, sorry, this is the contributions of each aspect. So your CapEx, your OpEx, foundations and so on, and how much that contributes to the LCOE, the levelized cost of energy for these marine energy technologies, or tidal in this example. And you can see that the installation and O&M accounts for between 25 and 40% of the levelized cost of energy of these technologies. So it's the biggest area, other than cost of capital, on a technical point of view, the biggest area for cost reduction. And if we're to make these technologies a success, we really need to drive that down to a much lower percentage. And obviously, it's the greatest element of risk. O&M continues for 20, 30 years. So there's a lot of repeat operations and a lot of opportunity for things to go wrong. So if you aren't prepared to, with the mindset that you're going to have to maintain your device in an offshore environment, costs can start to escalate quite rapidly. And that's where we've been helping the developers within Encore. So the nice thing about Encore is there's 4 relatively early stage developers, which is the perfect time to start considering how you will maintain and install your device, and which has been a challenge for other developers, which we've worked with, where they build the device and O&M and installation hasn't been considered with the weight which we would say it should be. And then that starts to bring around the challenges of how do we effectively install these technologies with the equipment which is readily available and cheap for the sector. So we've been working with all 4 developers to integrate safe, reliable and cost-effective design for installation and O&M. Mainly on so foundations, moorings, and also dynamic power cables, and then obviously feeding that into the actual O&M strategies. So breaking down how we'll deploy and maintain the technologies into step-by-step processes, which can then be taken forward to help de-risk and come to a good understanding of what the cost will be for these technologies, and then iterate through that process again to meet the targets for these developers. The second aspect of de-risking technologies, so the first, as I said, is design, and designing for assets which are readily available, so the vessels in the sector, and the other aspect is having the equipment, or knowing the equipment which is most cost effective and reliable to use, and those two aspects are obviously very interlinked. One of the biggest challenges we have, certainly within tidal energy and wave, is that we have to achieve scale to bring down the costs, as with all sectors. But to do that, we need larger vessels with larger crane capacities. And the challenge at the moment is that these vessels that we're using, chartering, they're all engaged in the offshore oil and gas industry. So the renewables, tidal, wave sectors is heavily reliant on the oil and gas market. So as we see now with the oil and gas industry and the impacts on prices there, that has had knock-on effects to our vessel costs, which has been really detrimental, I would say, for short-term progress. So this year we've done around 2 operations for tidal developers. In a normal year we usually do between 5 and 10, so it's really had quite an impact. So what we're doing to try and address that, and what Encore's helped us to do, is to secure €2 million of investment. Through that, we've now acquired our own vessel. It's an ex-oil and gas vessel, a DP2 vessel, and our plan is to integrate some specialist equipment which meets the needs of our clients in both wave, tidal, and other sectors, including floating wind as well. So that the vessel will help us to dissociate from that reliance on the oil and gas market, as I said, helping to de-risk the technologies by preparing a very specialist and optimized asset for these developers, so that we're not having to get new vessels on each operation. So we're repeat operations, repeat assets, specialized assets for these developers to help drive down the risk from a service provider perspective, rather than just from the technology developer's perspective. And hopefully it'll be a success. And that's all we've got for today. So we've all got stands here. So in Inyanga, we've got a stand just over there. So please do come and speak to us about anything that we spoke about today, the Encore project, or BV's contribution, or our own contribution, and Artalia as well. I'll let you say where you guys are based so that people can come and find you.
Yes, so the BV stand is at the entrance on the left part, on the right part, sorry. So you can, you will be welcome to come and visit us and have some more questions. And do you want to have a word?
Yes. Yes, in Artalia we are involved in the Encore project. We provide a resource assessment to the technology developers at 4 pilot sites. So the aim is to provide the environmental conditions to assess the potential of energy production of the pilot sites. And you can come and meet us at 4 at Pavillon Pays de la Loire, when there is a presentation of several Interreg projects, and Encore is funded by Interreg, by the Interreg funds. Thank you very much.